Hi all, this is going to be a quick video related to homework 6-13, which is our weekend homework. So here we go. If you open up your homework 6-13, the first question is review from average rate of change. So we just wanted to remind you that we can apply the average rate of change to any type of function. And just a reminder, the formula for the average rate of change is change in y over change in x, or y2 minus y1 over x2 minus x1. So it depends on which interval we're looking at, and the interval can either be written as from A to B. It can also be written as this notation here with brackets, or it could be written as an interval like a sandwich like this, 2 less than or equal to x less than or equal to 4, or like this, 2 to 4. But basically it means from x equals 2 to x equals 4, okay? So we're going to look at this first one, which is a review question that you guys actually did in the past. So this is going to be change in y over change in x. So if we look at x equals 2 and x equals 4, we're interested in the average rate of change over that interval. So at x equals 2, it's going to be the point 2 comma 20. And at x equals 4, we see we have 460. So we're going to do change in y over change in x, okay? So I want you to set that up right now and see what you get. Oop. So pause the video and set it. Okay, so I set up my equation. I did 60 minus 20, and I did 4 minus 2. 60 minus 20 is 40, 4 minus 2 is 2, and I got 20. So this means for every 1 unit increase of x, the y values are increasing by about 20 units on average over the interval. So basically the distance in miles traveled in this question is increasing by about 20 miles for every 1 hour. On average. The average speed is 20 miles per hour, okay? So now let's take a look at the next one. Now this one gives you an equation that's an exponential. So we put this here because we wanted to review average rate of change with an exponential function. So it's giving you the exponential function, and it's saying, can we predict the approximate average rate of change of the temperature of hot chocolate over the interval from x equals 0 to x equals 6? So remember, if this is x representing the time in minutes, this is really time 0 minutes to time 6 minutes. So in this question, we have an equation, and it looks kind of different than the graph or a table. So what we want to do first is go to y equals and type in our equation. And then once you have your equation in there, you're going to look on the table at x equals 0 and x equals 6, okay? So if you scroll to x equals 0, we're going to copy down the value, 0, 159. And then x equals 6, we're going to have 6 comma 105.41. Okay, so now set up your average rate of change, and let's see if you get the right answer. Okay, so I did the setup. I did 105.41 minus 159 in my numerator for my change in y. For my change in x, I did 6 minus 0, and I got an answer of a negative number, negative 8.931. So keep in mind that this had to do with the temperature of the hot chocolate over time. So for every 1 minute that has elapsed, it looks like the temperature of the hot chocolate in degrees Fahrenheit is cooling down by an average of 8.93 degrees Fahrenheit. Okay, so that's what it means in the real life setting. The temperature of the hot chocolate is going down or cooling down. Okay, so now let's get into the new stuff. So here we have our review of our basic equation of exponentials. We have y equals ab to the x, and then we have this other one here. Now let's remind ourselves that the a value, which is the number in front, is the initial value, a. It's also known as the y-intercept. And the other thing that you have here is p. P is the principal amount. So let's say we're talking about money in the bank. The principal amount is the initial amount of money that you put in the bank. Now we also have a growth factor or decay factor. That's the base B. And it's also equivalent to 1 plus the rate if it's growing, or 1 minus the rate if it's decaying. Remember, the rate has to be a decimal, so keep that in mind. Now to get the rate, that's denoted by the letter R, lowercase r, and we just have to remind ourselves it's a decimal. Okay, so that's review. If it's usually like one time a year, then there's a 1 in the front of the X, so that would be considered annual. Okay, so now let's move on to the next part. Now let's say I want to put some money in the bank. You guys know that money in the bank, it can be compounded in different ways. So if I were to open up a bank account, they're going to give me an interest rate R. Okay, so that is the first thing, the rate or interest rate if we're talking about money. And remember, the rate is a decimal. So usually they're going to tell you that that interest rate is compounded, which means calculated a different number amount of times per year. So if you have a loan, if you're taking out a loan to get a car or whatever it is, they're going to tell you that they're compounding the interest, annually or semi-annually or quarterly or monthly. Those are the most common ones that we see, okay? So the amount that we start with, whether it's, let's say I'm taking out a loan for a car, that's called the P, the principal amount, okay? The principal amount or initial amount. So that's the amount that I put in the bank. The initial amount I put in my bank account. That's the amount that I'm taking out for my loan on my car. Let's say I'm taking out a car that's $15,000. That's the principal or initial amount. Now, the N is representing the number of times the interest is being calculated or compounded per year. And that is the new stuff. The number of times that the interest compounded per year. Okay? So let's say they tell me that the interest is only calculated once a year, then that means that it's annual, okay? So that's going to be the N, and that's going to be once a year. So I'm going to put a 1 here in this first blank, annual. Let's say they say the interest is being compounded twice a year. That's called semi-annual. Like, oh, the semi-annual sale means twice a year. Let's say it's being compounded quarterly. You guys know quarters. That should be 4 times a year. If they said they were compounding the interest monthly, that's 12 times a year. And those are the most common, would be monthly and quarterly and annually, okay? If they said weekly, that would be 52 times a year, and daily is 365 times a year, okay? So keep in mind the word compounded, it's going to go in for the letter N. Oh, there's another N here. So N shows up twice in the formula. And then also we have a T for time, okay? So this T is time elapsed, and usually it's in years, okay? For example, in years, total amount of time in years. Okay, that's what we put in there. So let's say I'm putting in $100 in the bank, then the $100 would go in for the P, and let's say it was compounded at a 3% rate, the 0.03 would go in for the rate, and it was compounded monthly, then I would put in the 12 in here for the N, and then let's say I wanted to know how much money I have at the end of 10 years. That T would be the time, 10 years, okay? So the last one is the letter A here on the left-hand side. That is going to be the final amount at the end of the time period. Okay, so I know this is a lot of letters and stuff, but it actually makes total sense, and you'll see when we get down below. So now we have this equation. So notice the equation above is in this format, okay? P 1 plus R over N to the NT. So here we go. Teresa is putting money in the bank. This is the equation she has here. It says how often is her interest being compounded, okay? So you just want to look for the value of N. So if you look back on the top here, the N is located in the 2 places. It's located in the bottom and in here. So this is N, N, okay? So if you look in that same location in this question, you see 12, 12. So that means the N equals 12, which means that it is, I'm hoping you're saying monthly, because there are 12 months in a year. So that means that they're calculating the interest every month. Okay, next one. Example 2, $5,000 is invested. So let's circle that, $5,000. That's going to be the P, the principal amount, or initial amount in the bank. At an interest rate, let's circle that, 3.5%. That's going to be the rate. So remember, as a percent, that's great, but we got to make it a decimal. So if you move it to the left, it's 0.035. And then it says compounded quarterly. So that's N. The N is 4 because there's 4 quarters in a year. There's 4 quarters in a dollar, right? There's 4 quarters in a basketball game, right? So it says no money is deposited or withdrawn. We just leave that money in the bank using the formula below. Determine, sorry, it's really the formula above. Determine to the nearest cent how much money will it be after 12 years. Okay, so the 12 is the time, the total time elapsed. Okay, so now we're just going to plug in using the formula above. So the formula is A equals P 1 plus R over N to the NT, okay? So we are looking for A, which is the final amount. So let's plug in our initial amount, which is the 5,000. That's going to go in here. Now we're going to do 1 plus because we're retaining the initial amount of 5,000, and now we're adding. Now the rate is 0.035, so that's going to go in here on the top for R. And then the N is 4 because it's quarterly. So that's going to go here and here, 4 and 4. And then the T is the time. The time is 12 years. So we're going to plug that in for here, 12. Okay. So once you have all that information plugged in, it's pretty straightforward. You just have to plug it in to the calculator and get your answer. Okay. So take out your calculator, go to your home screen, and type in the equation exactly how you see it. 5,000, 1 plus fraction 0.035 over 4, and then close parentheses, caret, and then our exponent is 4 times 12. You could either put 4 parentheses 12, or you could just do that, whatever. Let's delete that parenthesis and hit enter. And then usually we're rounding money to the nearest cent because it's dollars and cents. So it's going to be 0.92. So 7595.92. $7,595.92. Okay. Let's check it to make sure I have the right amount. 7595.92. That's it. There you go. Now you try the next two down below. Thank you.